Hi, today is Wednesday, Hump Day, August 13th, 2025. So I have 2 more days to go today and tomorrow. Then it's our Korean Independence Day, Friday. We got independent from Japanese rules of 35 years that started in 1990 and ended on August 15th, 1945, when the U.S. bombed the Nagasaki and Hiroshima with A-bombs. So we got independence at the time. On tomorrow night, I would be traveling to Gwangju City, my hometown, where my family is, my wife and two daughters. And of course, my wife is unruling, right? Unruled, very independent, doesn't listen to me and despise me and don't respect me and you name it, right? Today we are going to learn about AI chip, right? This article is from IBM. I just stored this post by reading the headlines. I never read this article before, and the reason I am trying to read an English article each day is to keep up with my English, right? To hone in on my English so that I can stay up to the par where I would feel competent about my English. I love foreign languages, and English is also the number one language that I would like to continue to learn and master so that I could use it when it comes to communicating with foreigners, especially Americans, Canadians, all other Australians and New Zealanders, the UK people, because English is a beautiful language, bastard language. But Korean language is much better, right? And German is also one of my favorites. I'm learning Chinese now, so I would be multilingual, but the English is the number one important language that I'd like to keep with me until to the tomb, right? So if you happen to want to teach me English, just contact me. And also, in 3 years' time, I have to retire, so that I would like to get a job in the US or Canada or Australia or New Zealand in the services sector or management sector or the tourism or import-export business. Or if you want to open an overseas branch, I would be the branch manager or helper, whatever it is. 1 year to 3 year contract would be just good, because I would like to travel all over the world. And then, of course, personally, I would be interested in import and export business. So if you have a good idea, always contact me. Just leave your comments in my reply section. Then we can communicate, right? So let's learn about AI chip. Why suddenly am I interested in the AI chip? Because I am a KT employee, right? KT is Korea Telecom, the number one cloud service provider and AI service provider in Korea. But we are also the largest telecom carriers. So if you want to have some kind of business with KT, just contact me. We provide corporate internet lines, corporate security services, including CCTV and the unified threat management devices, VPNs, or mobile services, right? And iPads, iPhones, Samsung Galaxy phones, and the software. We are the Microsoft's partner, right? CSP. So we sell Microsoft products and Azure service. So that's why I am interested in the AI. We talk about AI chip and Aiczywiiran and dynamic memory chip and computers, laptops, servers. What else? EAS, PIAS, SaaS, all sorts of services. So the basic bottom line building block is AI chip, right? NVIDIA to China and 15% cut to the US government, right? This article was written last year, 6 June 2025. The authors are Mesh Flinders, IBM Think, Ian Smalley, Senior Editorial Strategist. What is an AI chip? Artificial intelligence chips are specially designed computer microchips used in the development of AI systems. Unlike other kinds of chips, AI chips are often built specifically to handle AI tasks, such as machine learning, ML, data analysis, and natural language processing, NLP. From the Jeopardy win of IBM Watson to OpenAI's release of ChatGPT to self-driving cars and generative AI, the potential of AI appears limitless. At the moment, and most major tech companies, including Google, IBM, Intel, Apple, and Microsoft, are all heavily involved in the technology. But as the complexity of the problems AI tackles increases, so do demands on compute processing and speed. AI chips are designed to meet the demands of highly sophisticated AI algorithms and enable core AI functions that aren't possible on traditional central processing units, CPUs. The term AI chip is broad and includes many kinds of chips designed for the demanding compute environments required by AI tasks. Examples of popular AI chips include graphics processing units, GPUs, field programmable gate arrays, FPGAs, and application-specific integrated circuits, or ASICs. While some of these chips aren't necessarily designed specifically for AI, they are designed for advanced applications, and many of their capabilities are applicable to AI workloads. Why are AI chips important? The AI industry is advancing at a rapid pace, with breakthroughs in ML and generative AI in the news almost every day. As AI technology develops, AI chips have become essential in increasing AI solutions at scale. That's a good expression, man. That's the expression I like. AI chips have become essential in creating AI solutions at scale. AI chips have become essential in creating AI solutions at scale, right? At scale. Not to the scale, or by the scale, or by scale, is at scale. For example, developing a modern AI application like facial recognition or large-scale data analysis using a traditional CPU, even an AI chip from a few years ago, would cost exponentially more. Modern AI chips are superior to their predecessors in four critical ways. They are faster, higher performing, more flexible, and more efficient. Speed. AI chips use a different, faster computing method than previous generations of chips. Parallel processing, also known as parallel computing, is the process of dividing large, complex problems or tasks into smaller, simpler ones, while older chips use a process called sequential processing, moving from one calculation to the next. AI chips perform thousands, millions, or even billions of calculations at once. Interesting. Parallel processing. This capability allows AI chips to tackle large complex problems by dividing them up into smaller ones and solving them at the same time, exponentially increasing their speed. So parallel processing, different, right? It's not a sequential processing, parallel processing. So that speeds are enormously mind-boggling, blown away speed, flexibility. AI chips are much more customizable than their counterparts and can be built for a specific AI function or training model. ASIC AI chips, for example, are extremely small and highly programmable and have been used in a wide range of applications from cell phones to defense satellites. Unlike traditional CPUs, AI chips are built to meet the requirements and compute demands of typical AI tasks, a feature that has helped drive rapid advancements and innovations in the AI industry, right? Flexibility, different design, specific design. Good. Efficiency. Modern AI chips require large energy than previous generations. This is largely due to improvements in chip technology that allow AI chips to distribute their tasks more efficiently than older chips. Modern chip features like low precision arithmetic enable AI chips to solve problems with fewer transistors and therefore lesser energy consumption. These eco-friendly improvements can help lower the carbon footprint of resource-intensive operations like data centers. Okay, so we hear many things about the electricity shortages with the data centers. Data centers usually gobble up a lot of energy, electricity, and HVAC, air conditioning, and constant temperature regulation. It's just that AI chip consumes less energy, but it's just that they use lots of AI chips, right? China. So that's why the AI centers, data centers, cloud centers, they use a lot of electricity. Interesting. Performance. Since AI chips are purpose built, often with a highly specific task in mind, they deliver more accurate results when performing core tasks like natural language processing, NLP, or data analysis. This level of precision is increasingly necessary as AI technology is applied in areas where speed and accuracy are critical, like medicine. Precision. Achieving AI readiness with a hybrid cloud. Good. Led by top IBM thought leaders, their curriculum is designed to help business leaders gain the knowledge needed to prioritize the AI investments that can drive growth. Challenges facing AI chip technology. While there are many qualities that make AI chips crucial to the advancement of AI technology, there are also challenges facing the widespread adoption of these powerful pieces of hardware. Taiwan-dependent supply chain. According to The Economist, chip makers on the island of Taiwan produce over 60% of the world's semiconductors and more than 90% of its most advanced chips. Yeah, I visited Taiwan 3 times. They are very smart. They are hardworking, and it's a rather very sad country. I would like to unify with Taiwan, right? Korea, South Korea, and Taiwan becomes one nation. Then we unify North Korea. Then we would be very strong, right? Maybe some parts of China can join us, and then later on China can be unified together, right? So we would be whole new one nation. That's my fantasy. Unfortunately, critical shortages and a fragile geographical situation are constraining growth. NVIDIA, the world's largest AI hardware and software company, relies almost exclusively on Taiwan Semiconductor Manufacturing Corporation, TSMC, for its most advanced AI chips. Taiwan's struggle to remain independent from China is ongoing, and some analysts have speculated that a Chinese invasion of the island might shut down TSMC's ability to make AI chips together. So that's why they moved some of their production to Japan. Pace of innovation. As developers build larger, more powerful AI models, computational demands are increasing faster than advancements in AI chip design. Improvements in AI hardware are coming, with companies exploring areas like in-memory computing and AI algorithm enhanced performance and fabrication to increase chip algorithmic efficiency. But they aren't moving as fast as the increases in computational demand of AI applications. Okay. Power requirements. As performance demands increase, AI chips are increasing in size and requiring greater amounts of energy to function. Modern, advanced AI chips need hundreds of watts of power per chip, an amount of energy that is built difficult to direct into small spaces. Significant advancements in power delivery network (PDN) architecture are needed to power AI chips, or their performance will be affected. Powers, electricity. How do AI chips work? The term AI chip refers to an integrated circuit unit that is built out of semiconductor, usually silicon, and transistors. Transistors are semiconducting materials that are connected to an electronic circuit. When an electrical current is sent through the circuit and turned on and off, it makes a signal that can be read by a digital device as 1 or a 0. In modern devices such as AI chips, the on and off signals switch billions of times a second, enabling circuits to solve complex computations using binary code to represent different types of information and data. Chips can have different functions. For example, memory chips typically store and retrieve data, while logic chips perform complex operations that enable the processing of data. AI chips are logic chips, processing the large volumes of data needed for AI workloads. Their transistors are typically smaller and more efficient than those in standard chips, giving them faster processing capabilities and smaller energy footprints. Parallel processing. Perhaps no other feature of AI chips is more crucial to AI workloads than the parallel processing feature that accelerates the solving of complex learning algorithms. Unlike general purpose chips without parallel processing capabilities, AI chips can perform many computations at once, enabling them to complete tasks in a few minutes or seconds that would take standard chips much longer. Because of the number and complexity of computations involved in training of AI models, AI chips' parallel processing capabilities are crucial to the technology's effectiveness and scalability. Types of AI chips. There are several different kinds of AI chips that vary in both design and purpose. GPUs, FGPAs, NPUs, ASICs, AI chip use case. Let me go to NPUs, right? Neural processing units, NPUs, are AI chips built specifically for deep learning and neural networks and the large volumes of data these workloads require. NPUs can process large amounts of data faster than other chips and perform various AI tasks, such as image recognition and NLP capabilities for popular applications like ChatGPT. So ChatGPT uses NPUs, right? NLP, NPU, they use both, and neural, right, and image processing. So NPUs are mainly used for ChatGPT, and it stands for Neural Processing Units, NPUs. Are AI chips built specifically for deep learning and neural networks and the large volumes of data these workloads require. NPUs can process large amounts of data faster than other chips and perform various AI tasks such as image recognition and NLP capabilities for popular applications like ChatGPT. GPUs, graphics processing units, or GPUs, are electronic circuits designed to speed computer graphics and image processing on various devices. Video card, right? They are inserted in the video card, including video cards. Yeah, there we go. System boards, mobile phones, and personal computers, right? Even the mobile phones. Although they were initially built for graphics purposes, GPU chips have become indispensable in the training of AI models due to their parallel processing capabilities. Developers typically connect multiple GPUs to the same AI system so they can benefit from even greater processing power, right? AI model training, GPUs. FGPAs, field programmable gate arrays, FPGAs, are bespoke, customized, right? Bespoke, programmable AI chips that require specialized programming knowledge, unlike other AI chips, which are often purpose-built for a specific application. FPGAs have a unique design that features a series of interconnected and configurable logic blocks. FPGAs are programmable on a hardware level, enabling a higher level of customization. ASICs, application-specific integrated circuits, ASICs, are chips custom-built for AI applications and cannot be reprogrammed like FPGAs. However, since they are constructed with a singular purpose in mind, often in the acceleration of AI workloads, they typically outperform their more general counterparts. Right? So here, MPUs, I would like to go back to FGPS, right? Field programmable gate arrays are bespoke, programmable AI chips that require specialized reprogramming knowledge. Unlike other AI chips, which are often purpose-built for a specific application, FPGAs have a unique design that features a series of interconnected and configurable logic blocks. FPGAs are reprogrammable on a hardware level. Wow. Enabling a higher level of customization. So they can change the chip arrays physically, right? FPGAs. But ASICs, you can't, right? Different. AI chip use cases. As a critical piece of hardware in the design and implementation of one of the fastest growing technologies on the planet, AI chip use cases span continents and industries. From smartphones to laptops to more cutting-edge AI applications like robotics, self-driving cars, and satellites, AI chips are quickly becoming a critical component across all kinds of industry. Some of the more popular applications include autonomous vehicles. AI chips' ability to capture and process large amounts of data in near real time makes them indispensable to the development of autonomous vehicles. Through parallel processing, they can interpret data from cameras and sensors and process it so that the vehicle can react to its surroundings in a way similar to the human brain. Right? Here, data is singular, right? For example, when a self-driving car arrives at a specific light, AI chips use parallel processing to detect the color of the light, the positions of other cars at the intersection, and other information critical to safe driving operation. Autonomous driving. All about camera images, sensor input, and parallel processing. Edge computing and edge AI. Edge computing, a computing framework that brings enterprise applications and additional computing power closer to data sources like Internet of Things devices and local edge servers, can use AI capabilities with AI chips and run ML tasks on edge devices. With an AI chip, AI algorithms can process data at the edge of network with or without an internet connection in milliseconds. Edge AI enables data to be processed where it is generated rather than in the cloud, reducing latency and making applications more energy efficient. So for example, Katie, my company, can build a edge network right in your campus, university campus, factory campus, corporate campus, or compound. Then it doesn't require internet, right? Your lab, for example, or your company, your manufacturing site can access our cell tower right there and calculate, right? All the important network mobile equipment is at the base station, at the antenna tower, so that it doesn't have to go through the KT's core network. So it is called edge computing. But let me go over it one more time. Edge computing and edge AI. Edge computing, a computing framework that brings enterprise applications and additional computing power closer to data sources like Internet of Things, IoT, devices, and local edge servers, can use AI capabilities with AI chips and run ML tasks on edge devices, right? Yeah, there we go, right? We just bring the cell tower to you and applications. With an AI chip, AI algorithms can process data at the edge of network with or without an internet connection in milliseconds. Edge AI enables data to be processed where it is generated rather than in the cloud, reducing latency and making applications more energy efficient. Large language models. An AI chip's capability to speed ML and deep learning algorithms helps enhance the development of large language models, LLMs, a category of foundational AI models trained on large volumes of data that can understand and generate natural language. AI chips parallel processing helps LLMs speed operations in neural networks, enabling the performance of AI applications like generative AI and chatbots. It's about language understanding, large language models. It's not a small language models, it's a large language models. Robotics. AI chips, ML, and computer vision capabilities make them an important asset in the development of robotics. From security guards to personal companions, AI-enhanced robots are transforming the world we live in, performing more complex tasks every day. AI chips are at the forefront of this technology, helping robots detect and react to changes in their environment with the same speed and subtlety as a person. Interesting. Related solutions, cloud infrastructure center, IT infrastructure solutions, cloud infrastructure solutions. So basically, AI chips are four kinds: ASICs, NPUs, GPUs, FPGAs, right? But GPUs are quite important than NPUs, right? NPUs, neural processing units. GPUs are everywhere: robotics, autonomous vehicles, AI, generative AIs, and everything. The main advantage of GPUs is that it is a parallel processing. Well, thanks for listening and have a great Hump Day Wednesday. Thank you and bye-bye.